Hey everybody, my name is Damon Knight and welcome back to my YouTube channel and my ongoing series of A Complete Noob's Guide to Astrophotography. In today's video, we are going to be focusing on deep space astrophotography, taking pictures of galaxies and nebula. Specifically, we are going to be talking about the process of actually taking those pictures. Now, deep space astrophotography is very different from planetary astrophotography. The objects you're taking pictures of are quite significantly further away, to put it mildly, and much less bright than the planets are. This means not only is light pollution going to be a bigger factor, but so is the speed of your telescope, for example. With planetary, you're probably only capturing a couple of minutes worth of data or pictures. But with deep space astrophotography, deep space objects, you could be capturing hours and hours and hours of data. Tracking is also much more important than it is with planetary, kind of as a result of the length. Since you're going to be keeping your telescope aimed at a moving target for such a comparatively long amount of time, you have to worry about it moving out of frame or generating star trails, things like that. I know all of this can seem a bit overwhelming, so we're going to take a step back and just talk about what we're doing, why we're doing it. So let's, hopefully break things down into something a little bit more digestible. So, how does deep space astrophotography work? Well, like I mentioned, you're capturing a lot of data, and honestly, you want to capture as much as possible. And basically, we do this by taking a bunch of pictures and stacking them together. But what does that actually mean and do? And obviously this is a bit oversimplified, but pictures have an exposure time, right? The longer the exposure of an image, the more data you're going to get. When you take kind of a normal everyday picture, the exposure is going to be super, super short, fractions of a second. If you have a modern smartphone, right, you might notice they have a low light mode, and that picture is like 3 or 5 seconds. And you'll notice that that picture winds up a whole lot brighter than it would be if it was super short, and that's because it's collecting more data. Astrophotography uses the same concept. You want to take as long of a picture as possible to get as much data as possible. But taking a super, super long picture can be very difficult for a whole bunch of reasons, right? Maybe an airplane flies across the sky, or there's clouds, or, you don't have precise enough tracking to keep everything perfectly still. So we take shorter, still as long as you can, but shorter pictures, and we stack them together. So the idea is if you take five 30-second pictures and stack them together, you end up with roughly the equivalent of a 2.5 minute picture. This is useful because you can also, throw out individual pictures with those clouds, planes, star trails, whatever, without wasting those other images that might be just fine. So, that being said, why do you want to make the individual pictures kind of as long as you can instead of just taking a whole bunch of super short ones? Especially if you're stacking them together anyway, right? Wouldn't you wind up with just as good of a picture with more short ones as long as the total imaging time winds up the same in the end, and you'd have even less of an image issue of those bad images ruining things? Yes and no, honestly. There's a really long explanation about signal to noise ratios and things like that and finding optimal exposure time. But there's an even simpler reason why we don't usually do that. And that is just the more individual pictures you take, the longer stacking them together takes. As an example, I recently finished a picture that is an over 80-hour long exposure when stacked. Now, I know that sounds like a crazy large amount of time. Don't worry, you don't need to do that long unless you're crazy like me. Um, when you're just getting started, an hour or two or three total is plenty. Um, I take 15-minute long pictures to stack together. So for my 80 plus hour project, that ended up with a bit over 300 images total to stack together. If I had taken 30-second pictures to stack together, that would have been like 9,600 or more pictures. Most computers just melt when you try to stack that much data together. It's just too much. When you're just starting out too, right? Don't begin to worry about 15-minute long exposures. That's quite long and challenging. It's totally reasonable to start out, if you have some amount of tracking with 15 or 30-second exposures to stack together. Just remember to try to keep your total number of images to something reasonable that your computer can handle. You will still get some absolutely amazing pictures, and I'll be showing you some right now that I took with shorter exposures. Matter of fact, this in the background here was taken with, I want to say, like 30-second exposures. I'll have to look, but something along those lines. So you can get really, really great pictures. It's also worth knowing that how long of a picture you can take is going to be limited by the amount of light pollution that you have. If you're in a place where the sky is not very dark at night, then longer exposure images will tend to get washed out. So you'll need to take those shorter exposures anyhow. You'll need to experiment for yourself, obviously, to find kind of the right balance for you. So now I want to talk very briefly about some of the different types of deep space objects. And there are really three main types that I want to make you aware of. And these are important because they could impact things like what sort of filters you might want or need. First up are galaxies, and I'm going to include just stars and star clusters and things like that in the galaxies category, because they're functionally the same for our purposes here. Galaxies are pretty straightforward. You don't really need anything special in terms of filters. As long as you can capture regular old color data, whether through filters on a mono camera or just the color camera, you can get pictures of galaxies. Some galaxies may be worth also using a narrow band filter like hydrogen alpha with, as they can reveal some nebula as well. And again, I'll show you an example here up on the screen of one like that. But just for starting out, I wouldn't worry too much about that. Just regular old normal color images are fine. Next up are what are called reflection nebula. I'm not going to go too deep into it, but a reflection nebula is basically just a nebula that has various gases and dust and things like that that are illuminated, lit up by nearby stars, and they're just reflecting the light from those stars back to us, hence the name. They'll usually also be kind of bluish in color as a result. And like with galaxies, really all you need are standard red, green, blue color data. There's not generally any narrowband data that you'll be able to collect. So, aiming narrowband filters at those is generally a waste of time. But then finally, we have what are called emission nebula. And unlike with reflection nebula, these don't just reflect light from nearby stars. They're generally actually like the gases and things like that get ionized and heated up, and there's neat stuff. But basically, they emit their own light, and you can take pictures with just RG, red, green, blue, and normal color data of those objects, but because they emit light in kind of funky frequencies, you can get really, really amazing extra detailed images and do really, really cool stuff with narrowband filters on those. So you really, really want narrowband for targets like that. Um, you know, Especially, hydrogen alpha and oxygen 3 and sulfur 2 filters. Now, I've left out a whole bunch of stuff, right? There's supernova remnants and there's planetary nebula and things like that. Um, Broadly speaking, planetary nebula, I just wouldn't worry about at all. Supernova remnants, you're probably fine with regular red, green, blue color images as well. So don't worry too much about things like that. All right, so I have just told you a whole bunch of information, and there's a lot more, honestly, on this topic, but I don't want to overwhelm you. So we're going to split the deep space astrophotography basics into two videos. Hopefully now you do at least understand a bit more of what we're doing and how we create some of these images for deep space astrophotography. And in the next video, I am going to start talking about some of the specifics around like telescopes and kind of speeds that you're going to want, or focal ratios you'll want for deep space astrophotography, and maybe also kind of focal lengths and things like that. And we'll talk a little bit more about cameras and mounts and some of the more technical stuff. Still going to try to keep things pretty simple for you all, but I don't want to give you too much of an information dump all at once. So we're going to call this here for this video. Please, I do hope you enjoyed this and found this helpful in your astrophotography journey. If you haven't, I always strongly recommend you go back and watch some of the other videos in this series to help lay a lot of the groundwork and build up that foundational knowledge that hopefully makes all of this make a bit more sense. And I hope you'll come back and see me again next video as we continue on with this. Thank you so much for watching.